Hello and welcome to this training session on NVIDIA Spectrum Networking, specifically focusing on the capabilities of NVIDIA NetQ. Today we will explore how NetQ transforms network operations from manual, reactive processes into proactive, data-driven workflows. Let's begin by defining NVIDIA NetQ. In modern data centers, manual monitoring is too slow. NetQ is a highly scalable network operations toolset designed to provide holistic real-time visibility into your NVIDIA Spectrum and Cumulus fabrics. Unlike legacy tools, it doesn't just check if a device is up, it validates configurations, correlates operational status, and tracks state changes across the entire data center. This allows you to drastically reduce the time it takes to identify whether a problem lies in the network or elsewhere, often referred to as mean time to innocence. Furthermore, NetQ is built to integrate seamlessly into CI/CD pipelines, making it essential for NetDevOps workflows. So what have we learned? NetQ is not just a monitoring tool, it is a validation engine for modern network operations. The important point here is that NetQ moves operations from reactive troubleshooting to proactive validation. This diagram illustrates the high-level architecture of NetQ. We start at the top with your data center network. NetQ agents, running on the switches and hosts, collect telemetry data. Instead of waiting to be polled, these agents stream data to the NetQ server. The server processes this information to provide two key outputs: real-time visibility into the network state and validation capabilities for troubleshooting. This flow ensures you are always looking at the current state of your network, not a snapshot from 10 minutes ago. Now let's look at how NetQ gathers intelligence. It utilizes lightweight agents installed directly on your switches and hosts. These agents monitor system configuration, interface performance, and resource utilization. Crucially, the agents aggregate specialized telemetry, such as what just happened events, and stream this data to the NetQ server using the efficient gRPC protocol. This architecture supports both on-premises and cloud deployments. Additionally, if you have third-party monitoring tools, the NetQ agent can stream data using the standard GNMI protocol, allowing you to integrate these rich insights into your existing dashboards without necessarily needing the full NetQ server interface. What have we learned? NetQ's power comes from distributed agents streaming high-fidelity data. The important point is the flexibility of the architecture. It supports NVIDIA's native tools while remaining open to third-party integrations via GNMI. Here we see the data flow. On the left, inside your switches and hosts, the NetQ agent actively collects telemetry data. This data follows two potential paths. The primary path is a gRPC stream sent directly to the NetQ server, which populates the user interface and CLI for analysis. Alternatively, the agent can use a GNMI stream to send data to third-party tools. This dual-path capability ensures you can leverage NVIDIA's deep telemetry regardless of your broader monitoring ecosystem. One of the standout features of Spectrum networking is what just happened, or WJH. Traditional counters might tell you that packets are dropping, but WJH tells you why, when, and where. This ASIC level telemetry that analyzes packets at line rate. If a packet is dropped due to an ACL deny, a buffer tail drop, or a routing loop, WJH captures the packet header information, specifically the 5-tuple or 12-tuple details, without needing to store the full payload. Events are grouped into categories like Layer 1, Layer 2, router issues, and congestion. Crucially, WJH doesn't just list errors, it provides detailed descriptions and recommended corrective actions. What have we learned? WJH eliminates the needle in a haystack problem of legacy troubleshooting. The important point is that WJH provides context, not just that a drop occurred, but exactly why it happened and how to fix it. This flow shows the life of a packet in a WJH-enabled switch. When a packet enters the switch, the ASIC checks it against forwarding and security rules. If the packet passes, it is forwarded normally. However, if the ASIC determines a drop or anomaly, it immediately generates a WJH event. The system captures the header and the reason for the drop, crucial for debugging, and streams the specific event to NetQ for analysis, giving you instant visibility into the problem. To diagnose application performance issues, NetQ offers flow analysis. This feature allows you to sample specific TCP or UDP flows and visualize their path through the network. It measures total transit time and latency at each hop, displaying the data on a color-coded graph: green for healthy, orange for high latency. This is critical for AI workloads where tail latency impacts job completion times. You can view average, minimum, and maximum latencies, as well as the 95th percentile values. Additionally, NetQ can display queue-length histograms to detect microbursts that standard polling might miss. Note that flow analysis requires Spectrum 2 or later switches. What have we learned? NetQ enables you to see the network from the application's perspective. The important point is that flow analysis correlates network pathing with latency metrics to pinpoint exactly where congestion is occurring. This diagram depicts a flow analysis session. Data flows from source to destination, passing through switch 1 and switch 2. As the flow traverses the network, each switch sends flow data, including timestamp and buffer stats, to the NetQ analysis engine. NetQ processes this to generate a latency heatmap and buffer usage report, allowing you to visually identify which specific hop in the path is introducing delay. Beyond traffic, NetQ monitors the health of the switches themselves. You can view comprehensive utilization statistics for CPU, memory, and disk space over time windows, such as the past 24 hours. A unique capability on Spectrum switches is process-level monitoring, which lets you see exactly which service-like switch or SX_SDK is consuming resources. This granularity helps distinguish between a general system overload and a specific runaway process. You can even configure the NetQ agent to monitor custom services or exclude others. Furthermore, you can set threshold crossing rules to trigger alerts when resource usage exceeds safety limits. What have we learned? NetQ provides deep visibility into the control plane health of your devices. The important point is that you can identify resource contention at the process level before it impacts packet forwarding. Here we break down switch health monitoring. NetQ tracks two main areas: system resources and process monitoring. Under system resources, it tracks global CPU, RAM, and disk stats. Under process monitoring, it drills down into service level usage for specific daemons. The system continuously checks: is a threshold crossed? If yes, it triggers an alert immediately. If no, it logs the data for historical trend analysis. NetQ is vital for change management through its validation and snapshot capabilities. You can run network-wide validation checks to ensure protocols like BGP and EVPN are operating as intended. Before making changes, you can take a snapshot of the network state. After applying a configuration change, you compare the current state against the snapshot to identify any unintended deviations. This look-back functionality is crucial for rollback decisions. NetQ also allows you to trace network paths and diagnose the root cause of connectivity issues by correlating configuration changes with operational status. What have we learned? NetQ serves as a time machine for your network, allowing you to validate state changes. The important point is that snapshots and validation checks prevent configuration drift and reduce the risk associated with network updates. This workflow shows the validation and snapshot process. We start with the current state and run a validation check. If it passes, we take a snapshot to preserve that known good state. We then apply changes to the network, resulting in a new state. We immediately compare this with the snapshot. If there is a deviation or error, we alert or roll back. If the state is stable and valid, we commit the changes. Finally, let's discuss NetQ's role in the NVIDIA Spectrum-X platform designed for generative AI. Spectrum-X tightly couples Spectrum-4 switches with BlueField-3 Super NICs. NetQ provides visibility into this specialized environment by monitoring ROS, RDMA over converged Ethernet, adaptive routing, and congestion control mechanisms. In multi-tenant AI clouds, NetQ helps ensure performance isolation, verifying that one tenant's heavy workload doesn't victimize another's. It validates the fabric to ensure it delivers the consistent, high-effective bandwidth required for massive AI jobs. What have we learned? NetQ is the observability layer for AI factories. The important point is that for AI workloads, NetQ moves beyond basic connectivity monitoring to validate the specific performance metrics, like ROS, throughput, and isolation, that AI applications demand. This diagram illustrates the Spectrum-X monitoring loop. The AI workload generates traffic sent via the BlueField-3 Super NIC to the Spectrum-4 switch. Both the Super NIC and the switch send deep telemetry to NetQ. NetQ aggregates this into ROS or congestion monitoring dashboards. This visibility allows operators to perform performance optimization, ensuring the AI workload runs at maximum efficiency. In conclusion, NVIDIA NetQ is an indispensable tool for operating modern spectrum networks. It combines deep ASIC-level visibility through WJH with high-level validation and flow analysis to manage complex data center fabrics. Whether you are running traditional enterprise apps or cutting-edge AI workloads on Spectrum-X, NetQ ensures your network is robust, efficient, and easily troubleshot. To get hands-on experience without risking production hardware, you can simulate a digital twin of your network using NVIDIA AIR. What have we learned? We've covered the full operational lifecycle from monitoring to troubleshooting. The important point is to start using these tools proactively. Validate your changes in NVIDIA AIR before deploying, and use WJH to solve problems before they impact users. This final diagram shows the continuous operation cycle. You start by designing and validating your network, ideally using NVIDIA AIR. You then deploy to production. Once active, you monitor and alert using NetQ. When issues arise, you troubleshoot using tools like WJH. Finally, you optimize the network based on these insights, feeding back into the design phase for future improvements.